In this video, we're going to take a look at adding and subtracting rational expressions, and we're starting with a problem that has rational expressions with common denominators. And this is a great start because in order to add and subtract, we need common denominators, so this puts us ahead of the game. When we have common denominators, all we have to do is combine our numerators over this one common denominator. So we're going to end up with one giant fraction over 3r minus 6, and all we have to do is subtract the numerators. Now it's important to remember that the numerator has to get completely subtracted. So not only does the r have to be subtracted, but the 1 has to be subtracted as well. So what we really have here is r plus 7 minus r minus 1 in this new fraction. So let's go ahead and simplify that and see what it gives us. This r and this r cancel each other out. Positive r minus r, those are gone. And all I end up with is positive 7 minus 1, which is 6, over 3r minus 6. Now that we've combined all of our like terms, all we have to do is see if anything here can simplify. I can simplify by canceling common factors, but I have to factor before I can find them. So what we're going to do is factor the denominator. It has a GCF of 3. If I divide 3r by 3, I just get r. And if I divide 6 by 3, I get the number 2. And in our numerator, we have the number 6. Now what I notice here is that 6 and 3 cannot cancel, but they can reduce. They have a greatest common factor of 3. So if I divide 6 by 3, I get the number 2. And if I divide 3 by itself, I get the number 1. That means my final answer will be 2 over r minus 2. Let's go ahead and take a look at an example that does not have common denominators and see how we can find them. Here's our next example. Now, when we don't have common denominators, what we need to make is the lowest common denominator to make our lives easier. In order to find the lowest common denominator, I have to find out if these two denominators have anything in common already. And I don't know if they have anything in common until I can see what they're made of, until I can see their factors. So we're going to start by factoring. The first thing we're going to do is factor the denominator on the left. The numerator we can just leave as x plus 6. But the denominator, we're going to find the two things that multiply to negative 6 that add to 5. Those two things are going to be 6 and 1. And if I want the 5 to be positive, the 1 has to be negative. So we end up with x plus 6 times x minus 1. Now on the next fraction, we're going to factor that denominator as well, and this time it's a little easier because this is a difference of squares. X is being squared in front, 1's being squared in back, which means my next fraction is x plus 1. That's a plus. I'm going to try that again. X plus 1 times x minus 1. Now that I can see what the denominators are made of, I can finally see what my common denominator will be. First and foremost, I already have an x minus 1 in common. So all I have to do is start looking for what's missing. The fraction on the left has an x plus 6 in the denominator that the fraction on the right doesn't have. So I'm going to have to multiply the fraction on the right by x plus 6. But if I multiply it by that on the bottom, I will also have to multiply it by that on the top, because we can't do something to one part of a fraction without doing it to the entire thing. On the other hand, the fraction on the right has an x plus 1 on the bottom that the fraction on the left doesn't have. So it's going to have to get multiplied by x plus 1. But if I multiply that on the denominator, I also have to multiply that in the numerator. Now we have common denominators. Now the common denominator is x plus 1 times x plus 6 times x minus 1. And both fractions have all three of those factors in the denominator. After we find the common denominator, we have to get the numerators ready to combine. So after I find the common denominator, my next step is to distribute. And by distribute, I mean actually multiply together the numerators. So the numerator on the left, I'm going to have to actually multiply together x plus 1 and x plus 6. We're going to have to FOIL that together. I'm going to get x times x, which is x squared, and then x times 6, which is 6x, and then x times 1, which is x, and then x times 1, which is 6. 6 times 1, which is 6. And the denominator is the entire common denominator, x plus 1, x plus 6, and x minus 1. the order of the factors in the denominator doesn't matter. I could put the x plus 6 in front or the x minus 1 in front. All that matters is that all three are there. On the right fraction, I have to distribute the x to both terms inside the parentheses. So I'm going to have x squared plus 6x. And again, I have that entire common denominator of x plus 1, x minus 1, and x plus 6. Now that I have common denominators and I've distributed the numerators, all I have to do is actually add the tops together. So we're going to combine like terms and make one fraction over the common denominator. I'll start with my x squareds. I have an x squared and an x squared that I'm adding together. So that's going to give me 2x squareds. Up next, I'll combine my x's. I have 6x, another x, that's 7x, plus this 6, that's 13x. And finally, I have the constant 6. All of these are over my common denominator of x plus 1, x minus 1, and x plus 6. Again, it doesn't matter what order I write those in. Now I'm finished adding. All I have to do for my last step is to check to see if anything simplifies. And I don't know what's going to simplify until I factor. So I'm going to have to factor the numerator to see if it has any common factors with the denominator. In order to factor the numerator, I will have to fake factor. We'll start by multiplying a by c. 2 times 6, which is 12. And the numbers will have to multiply to 12 and add to the 13 from the middle. Those values will be 12 and 1, and they will both have to be positive. So my factors here, I'm going to do it off to the side because I have one more step to fake factor. They're going to be 2x plus 12, because remember I have to put ax in both parentheses, and 2x plus 1, and then we'll have to divide 2 back out. If I take the factor on the left, it's divisible by 2. I can go ahead and divide 2x by 2. I will get x, and 12 divided by 2 is 6. And then the other factor, 2x plus 1, will stay exactly the same. I'm done fake factoring. That's my new numerator in factored form. And if we compare that to the denominator of x plus 1 times x minus 1 times x plus 6, we can check to see if they have anything in common. And they do. They both have an x plus 6. So we can cancel those out, replace them with a 1, which will give me my final answer of 2x plus 1 over the factored denominator, which I'll leave factored, x plus 1 times x minus 1. All right, we have one more example of finding common denominators. Let's go ahead and have a look. Here we go. Again, before I can find out what my lowest common denominator is, I have to find out if these two denominators already have anything in common. To find out if they have anything in common, we're going to go ahead and factor. We'll factor the denominator on the left by finding two things that multiply to 3 that add to 4. That's going to be 1 and 3, and they're both going to have to be positive. So on the left, we're going to end up with, let me move this over a little bit. Oops. Sorry, I'll just start that again. I'm going to write it over here. 2 over, here we go, x plus 1 times x plus 3. For my next fraction, I'll have to find two things that multiply to negative 6 that add to 1. Those numbers are going to be 2 and 3, and if we want a negative 6 but a positive 1, the 2 will have to be negative. So that denominator will be x minus 2, x plus 3. There we go. Now, to find out if they have anything in common, I compare the denominators. They both have an x plus 3. But the fraction on the right has an x minus 2 that the left side doesn't have. So it's going to have to get multiplied by x minus 2 over x minus 2. Oops, that's a minus 2. And the fraction on the right, the fraction on the left has an x plus 1 that the fraction on the right doesn't have. So it's going to have to get multiplied by x plus 1 over x plus 1. Now my factors have common denominators. They have all three factors, x minus 2, x plus 1, and x plus 3. So now I just have to get the numerators ready to combine, and I'll do that by distributing. So we're going to go ahead and distribute the 2 into the x and the negative 2. 2x minus 4 over x minus 2 times x plus 1 times x plus 3. And on the right, what I'm going to do is distribute the negative, because it's a negative 1. I'm going to distribute that to everything on the right. If you want to do that in a separate step, you're more than welcome to, but it's really not getting multiplied by anything else, so I'm going to go ahead and distribute that right now. If I distribute the negative from out front, I can change it into a positive and just change the signs of everything inside the parentheses. So instead of subtracting x, I can just say plus negative x. And instead of subtracting 1, I can just say minus 1. So I've distributed this negative to everything inside the parentheses. And that denominator again is x minus 2, x plus 3, and x plus 1. All right, all I have to do now is combine my numerators by combining like terms. So I have 2x and minus x. I'm just going to have x left over. And negative 4 minus 1 is minus 5. With my denominator, x minus 2, x plus 1, and x plus 3. Now everything is factored, and my numerator is simple enough to see that nothing cancels, so that is going to be my final answer. In the next video, we're going to take a look at solving rational equations.